Okay, today we're talking triangles, we're talking areas, and we're talking three different ways to find the area of a triangle. Let's go back in time to, I don't know when you first learned this, but you definitely did it in geometry, probably before. If you're given the right information, the area of a triangle is 1/2 base times height. Now, it has to be a specific case. If you've got a right triangle and you know this is the height and this is the base, that works. Or if you've got the triangle and somebody just happens to give you this distance, then it's fine. It could even have been that the height was outside the triangle and it looked like this. But any of those, you had to be given some specific info. And we're going to extend this a little bit so that you don't need as much given info, all right? Because that's difficult information to have sometimes. So our first new way to find the area goes like this. Let's take a triangle that's not a right triangle, and let's just turn it so that one of the sides is flat to the ground, to ground level, and let's just assume A, B, and C are the angles, and little a, little b, little c are the sides across from those angles. So this will be kind of the way we derive the law of cosines. If we drop in a little altitude here, and that's the height of the triangle, so I can just call it h. Now, I don't have that. I'm not telling you the problem is going to give you what h is, but this formula is going to be based on it. All right, so if you go back to the old school, 1/2 base times height, let's see what we have. So now that you've incorporated trig into your life, what is an expression for h? All right, so let's think about it. Sine, if I know what c is, I don't know this side length right here, but I do know c. So h would be opposite of angle A, and c would be the hypotenuse. I know it's a little backwards since h is for hypotenuse, but just play along. Sine of A is opposite over hypotenuse, h over little c. Now, if I rearrange that and I want an expression for h, I can multiply both sides by c and get little c times the sine of A. Okay, so now I have an expression for the height of this triangle in terms of one side C and one angle A. Now, if I put that together with my old formula, 1/2 base times height, I get 1/2. The base is actually little b, that's down here, and the height is C sine A. This is way number 2. If you know side angle side, right? If you know B, C, and angle A, then this is the perfect way to find that angle. All right, and we're going to do an example, but let me get to the third way. The third way is a formula that can be derived a few ways. One of them uses the law of cosines, but it's a complicated derivation. So we're just going to go straight to it. Sometimes it's called heroes, sometimes herons. I don't think we're exactly sure where it comes from, but it could be called both, and you should recognize both. And this formula, kind of straightforward, here it is. Area equals big square root of s times s minus a times s minus b times s minus c. All right, that should all be under the square root. And so what is s? S is the semi-perimeter. All right, semi just means half. A semicircle is just half a circle and so on. So a formula for S would be A plus B plus C all over 2. where A, B, and C are the side lengths. All right, and like I said, that comes from a pretty complicated derivation. If you're interested, you could find it easily. Google it, or we could talk about it later. But for this video's purposes, just realize what S is, plug in, and get your area. All right, so let's put these two new ones to use. Here on triangle RPQ, I'm given side angle side. So this is going to be a perfect setup for the first new way, 1/2 BC sine A. And again, as with the law of cosines, the A, B, and C are, let me actually make that area so I don't confuse it with the other A. They are irrelevant what letter it is. All right, the thing that matters is that the two sides and then the sine of the angle between those two sides is what we have. If I knew this angle down here, I wouldn't be able to do BC sine A because the 51 needs to be made by the 15 and the 16. It has to be a side angle side situation. All right, but I do have that, so it sets up perfectly. 1/2, 15, 16, sine 51 degrees. And I'm going to get my calculator out, and we'll confirm this. Okay, so here we are. Again, I want to make sure my calculator's mode is in degrees. All right, on this triangle unit, you want your calculator to pretty much always be in degrees. So my area is going to be 1/2, 0.5, times 15, times 16, times the sine of 51 degrees, and all of that is 93.26. All right, and if you want to be real proper, put units squared, whatever units the 15 and 16 are in. If they're in inches, then this would be square inches, and so on. The 93.26 is the important part right now, using our new formula. All right, let's move along. What if you're given three sides? Now, we talked about how to find an angle given side, side, side. You could use the law of cosines and work this thing out. But if we're just looking for area, then Heron's formula is probably our best bet. All right, big square root S minus A, S minus B, S minus C. So we need to know what S is. We know what A, B, and C are. S is the semi-perimeter, which is half the distance all the way around. So 14 plus 14 plus 5 over 2. So you have 28, 32 over 2, 16. All right, I think 16, 28. Oh, no, it's not. 28 and 5 is 33. 33 divided by 2 is 16 and a half. Pardon me. 16, yes, 16 and a half. So my area is the square root of 16 and a half times 16 and a half minus 14 times 16 and a half minus 14 times 16 and a half minus 5. You can simplify that before you type it in. You could type it in exactly like that. Let's make it a big square root of 16.5 times 16.5 minus 14, that's 2.5. I did divided by instead of times 2.5 times 2.5 times 16.5 minus 5 is 11.5, and that looks pretty good. We get 34.44 units squared. All right, so there's our first use with Heron's formula. Heron's formula is great if you are given side, 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 obviously, because it uses the three sides. Our new formula number 1, it uses two sides and the included angle, so given side angle side, that's going to be perfect. So if you're not given side, 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 or side angle side, like this, then what are you going to do about it? Well, in order to use these formulas straight up, we need to know what are all three sides, or what are side angle sides. So I would need to be given this side in order to go straight forward with 1/2 BC sine A. If this is what you're given, you're going to have to do a step first. You can try to find the other side, or you can try to find the missing angle. And given what we know with law of cosines involves all three sides. And if you're going to try to find an angle using law of cosines, you need to know the side opposite of it. So I'm thinking my only hope here, or my best hope, is to find this side using law of cosines, see what happens. So if that's my unknown, BC, I'm going to call it question mark for now. So remember how this works. The angle that I know and the side that I know, the one pair that I know, angle C and side C, that needs to be the first side I use and the last thing I write. So it's going to look like this. 11 squared equals 5 squared plus question mark squared. I like using a question mark as my unknown. Just reinforces the fact that this is my unknown. That's what I'm looking for. So anyway, b squared, side squared plus side squared minus 2 times 5 times question mark times the cosine of 115 degrees. Now remember, the 11 and the 115 correspond. It's the first thing and the last thing that I write. All right, so this one's going to be awesome when it plays out. It's going to end up being a quadratic. Watch how this happens. I get 121 equals 25 plus question mark squared minus, now I've got 10 times the cosine of 115 times question mark. So let's go to our calculator. 5 times 2 is 10 times cosine of 115 gives me negative 4.226. Okay, let's call it 4.2262. 4.2262 times question mark. All right, so I know that's not the prettiest, but what we have formed here is a quadratic equation. All right, let's move everything to one side. I'm going to move everything over to the right. I've got question mark squared, and then I have negative 4.226 times question mark, so that's plus 4.2262. And then I have 25, and I'm going to subtract from that 121, and that's going to give me a negative, I think a negative 96. 25 minus 121. Oh, good, negative 96. And what we have is a quadratic equation. Let me write it with x's. Just, I like the question marks, but in case that's bothering you, let's do it that way. All right, so now we're using the law of cosines to find a missing side length. What will happen if you find a missing side length with this, if it's not the one that corresponds to the 115, sometimes you'll have two options. Sometimes it'll end up being a quadratic like this that's not the prettiest thing ever. So what do you do if you have a quadratic like this? Well, there's a couple of things. You factor it, which this obviously I don't think is going to be factoring is the way to go because of that number in the middle. You can use the quadratic formula always. You could graph it and see where it equals 0. I think I'm going to go that way. I'm going to get my calculator, and I'm going to graph x squared plus 4.2262 x minus 96. Look at its picture and see where it equals 0. That's what the quadratic formula does anyways. It tells you where something equals 0. So let's just see where it equals 0. I think my window is going to need to be, let's see, these side lengths. I'm going to go out to 30 and I should cover it. All right, so I see one value. It's somewhere, let me actually go back to like 15. I found that 0 though. This is a parabola that's opening upward. One of these zeros is over on the left somewhere. We just can't even see it. This is the one that matters. This is the positive one that could possibly be a side length. All right, so let's see. 1, 2, 3, 4, 5, 6, 7. It's somewhere between 7 and 9. So I'm going to do left bound 7, right bound 9. I'm going to guess 8. And it turns out that it's 7.91. Okay, so far in this multi-step question, I've got 7.91 here. The other answer to the quadratic would have been a negative number that wouldn't make sense. Sometimes it does, sometimes it doesn't. We'll get to that more later. But all I've done so far is figure out that this side length is 7.91. Now what am I going to do? I've got options. I know all three sides, so I can use Heron's. Now that I know the 7.91, I could also do 1/2 BC sine A. So I'm going to do 5, 7.91, and sine of 115. All right, so once you've filled in more info, you've got more options. All right, let's see. 1/2 times 5 times 7.91 times the sine of 115 degrees is 17.9. All right, so let's wrap this up. Here are new options. The triangle trifecta. Old way, 1/2 base times height. If you get that, great. You usually won't. New way 1, 1/2 BC sine A. New way number 2, Heron's formula, using the semi-perimeter. There it is. All right. You might have a straight setup side angle side. Perfect. You might have side side side. Perfect. You might have to do a little investigating to get what you need. And in that case, you'll have options. All right. But don't forget your law of cosines because you might need it. So, shouts out to Heron or Hero, whichever his name was. Young out.